Alright, so in this video, we're going to be solving quadratic word problems that deal with projectile motion. So, number one, Jason jumped off of a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t is equal to negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. Alright, so before we dive into the problem, the projectile motion formula is h of t is defined by negative 16t squared plus v initial t plus h initial, where the v initial stands for the initial velocity and the h initial stands for the initial height. Alright, so if we match up the projectile motion formula with the given function, we know that the b term for the quadratic is a 16, and that's going to be the initial velocity that Jason jumped at. And the initial height, the c term, is given to be a 480. Right? So the 480 would be the initial height, and we know that the 16 would be the initial speed or velocity that he jumped from. So if we draw out the situation, he's jumping off of a cliff into the ocean. And the cliff is at an initial height of 480 feet. That's what the initial height was that he's jumping from. And he's jumping off in a parabolic motion. So if you draw the trajectory that he takes, it looks something like this. He reaches a maximum height, after which he comes down and eventually hits the water. All right, so this is called the trajectory that he takes, which is the path that some projectile takes upon being launched. So the trajectory. And that trajectory is given to be a parabolic function, which is defined by the given function. And so now that we know what the situation looks like, let's try part A. How long did it take for Jason to reach his maximum height? So the maximum height that he attains would be right at the vertex of the parabola. And we know how to get the vertex's x-coordinate and y-coordinate. But in this case, the x stands for the time it takes for him to reach that point, and the y would be the height that he attains after that time that he reaches the maximum height. So part A is asking for how long it took him to reach that maximum height, and they're pretty much asking you for the x value for the vertex because that aligns with the time. And we know what the formula is to get the x value for the vertex. X is equal to negative b over 2a. So if we apply it in this context, then x is actually time, and time would be negative of the b term, which the b term over here is a 16, over twice the a term, and the a term is a negative 16. All right, and negative over negative is an overall positive symbol, and we have in the numerator 16. Over twice 16 gives you a 32, and 16 30-seconds, that would simplify into 1/2 upon dividing the top and the bottom by 16. So we know that after 1/2 of a second, he reaches a maximum height. And that's going to be pretty much the x value for the vertex, 1/2. All right, now, so part B is moving on to ask what was the highest point that Jason reached. So that's pretty much asking you for the y value of the vertex, because the y value of the vertex would correspond to the height that he attains at the maximum point. So to get the y value of the vertex, you plug in your x value of the vertex, which we found to be 1/2, in place of every t. So the height after 1/2 of a second would be negative 16 times 1/2 squared plus 16 times 1/2 plus 480. All right, so now 1/2 squared would be a 1/4. So we have negative 16 times 1/4 plus 1/2 of 16 would be an 8 plus 480. Okay, and negative 16 times 1/4 would be a negative 4. So we have negative 4 plus 8 plus 480. And negative 4 plus 8 would be a positive 4. And 4 plus 480 would give us a 484. So we know that Jason reaches a maximum height of 484 feet after 1/2 of a second of being launched. And that would be part B, which gave us the y value for the vertex of the parabola. Okay. Now for part C, Jason hit the water after how many seconds? Well, he hits the water at this point over here, and so by them asking he after how many seconds he hit the water, they're pretty much asking us to solve for the time, meaning the x variable t. So t would be what after what time would it be that the height is equal to 0? All right, because when he hits the water, he would be 0 feet above the water. So if we plug in 0 for the height value, then we can solve for the t. And let's do that right now. So we have 0 is equal to negative 16 t squared plus 16t plus 480. All right, and to solve this quadratic, let's check if we can divide everything by a common factor. In this case, every term is divisible by negative 16. So we can divide both of our sides by negative 16. And that gives us a 0 is equivalent, I'll put that on here. 0 is equivalent to negative 16t squared divided by negative 16 would be a positive 1t squared. And then we have a 16t divided by negative 16 would be a negative 1t. And then 480 divided by negative 16 would be a negative 30. All right, so now to solve this quadratic, let's try to solve it by factoring. So two numbers I multiply to c, which in this case c is a negative 30, and adds to b, which b is a negative 1. And these numbers would be a 6 and 5, where the 6 would be negative. All right, so, and now 0 is equivalent to, if we factor the quadratic with the two terms, we have a t minus 6 as our first factor, and a t plus 5 as our second factor. And then upon setting both factors equal to 0, either t minus 6 would be equal to 0, or t plus 5 would be equal to 0. Then in the first case, t would be equal to 6 upon adding by 6. And in the second case, if we take away 5, then t would be equivalent to negative 5. All right, so, and this means that the original quadratic function has two x-intercepts, one of which is at 6 and the other one which is at negative 5. But in context, time can never be negative, so the negative solution is extraneous for us. And we know that Jason hits the water 6 seconds after launching himself off of the cliff. So the answer for that would be 6 seconds. All right, so projectile motion word problems with quadratics are a combination of knowing how to get the vertex of a parabola and solving quadratics. That's number one. So let's move on to number two, which says, if a toy rocket is launched vertically upward from ground level with an initial velocity of 128 feet per second, then its height, h, after t seconds is given by the equation, h of t is equal to negative 16t squared plus 128t, where the air resistance is neglected. So let's just draw out the situation. We know that the b term is a 128, and that would be the velocity that the rocket was launched from. And we see that there's no c term over here, so it's launched from ground level because the initial height would be 0. So if we draw it out, there's a rocket that gets launched from ground level. It reaches a maximum height. The trajectory would be a parabolic function, which is defined by the given function. And then it comes right back down, and that would be the path that it takes. And this function is given to be h of t is negative 16t squared plus 128t. So for part A, how long will it take for the rocket to return to the ground? So we know that it's on the ground when it's being launched. Now the question is, after how many seconds would it come back to the ground, which is going to be the second time that it touches the ground. And to solve for that, we're solving for the time it takes, so t would be what we're solving for, when the height above ground level is equal to 0. So we just have to plug in a 0 for the height value and solve that quadratic for the time. Right? So 0 is equivalent to negative 16 t squared plus 128 t. And there's no c term for this, so we can just factor out the common factor between both of our terms to solve this quadratic. And they both have a common factor of negative 16t. So negative 16t, if we factor that term out, then negative 16t times t gives us a negative 16t squared. and negative 16t times what gives us a positive 120t. Let's check what 120 divided by 16 is. That should be an 8. So again, negative 16 times negative 8 gives us a positive 128t. And now we set both of our factors equal to 0, which if negative 16t is equivalent to 0, then t would be equal to 0. And then we have the second solution, which if t minus 8 is equivalent to 0, then upon adding by it on both of our sides, we end up with a time value of 8 seconds. All right, so now the object's already on the ground after 0 seconds, which is what the first solution says. But when does it return back to the ground? And that would be after 8 seconds, which would be this point right here. That's when x is equal to 8, which in this case x is time, then the height would be 0. And we already had the initial point, which was 0, 0. And that in context just means that after 0 seconds, which was when it was first launched, the height above ground level was 0 feet. All right, so that's part A. Now part B, after how many seconds will the rocket be 112 feet above the ground? So it's the same idea. We're going to check when the rocket's 112 feet above the ground by plugging in a 112 for the height value, and then we're solving for the time it takes for the height to be 112 feet. All right, so again, we're solving for time. Time is what? When the height is equivalent to 112 feet. All right, so now we have 112 is equivalent to negative 16 t squared plus 120t. And upon subtracting away 112 on both of our sides, we end up getting a 0 is equivalent to negative 16 t squared plus 120t minus 112. All right, now always check if you can divide every single term by a common factor. In this case, I believe we can divide everything by negative 16. So let's do that. If we divide everything by negative 16 on both of our sides, then 0 divided by any number would be a 0. And I'll put that here. 0 is equivalent to negative 16t squared divided by negative 16 would be a positive 1t squared. And then we have a 128t divided by negative 16. Let me check what that is. That's going to be an 8. So we have minus 8t. And then negative 112 divided by negative 16. Let's check what that is as well. That's going to be a 7. So positive 7. And now we can solve this by factoring. So two numbers I multiply to 7 but adds to negative 8 would be a negative 7 and negative 1. So if we put this in factored form, then 0 is equal to t minus 7 times t minus 1. Again, because negative 7 times negative 1 would give you a positive 7, and negative 7 plus negative 1 gives you a negative 8. Once we have it factored, let's set both of our factors equal to 0, and I'll put that right here. So either t minus 7 would be equal to 0, or we have a t minus 1 would be equal to 0. And upon solving the first form, we have the time would be 7 seconds. And upon solving the second equation, we have the t value would be a 1. All right, so what that means in context, this is a parabolic function, and it's symmetrical about the axis of symmetry. So it's going to reach 112 feet above ground level, not once, but twice. And let's draw that out. So we have the 112 feet level, should be somewhere over here. And this rocket would reach a y value of 112 feet after 1 second, which is when it's first launched. And then again, when it's coming back down from the maximum height, after 7 seconds, it reaches a height of 112 feet again. All right, and that's going to be part B. So the answer would be after both 1 second and after 7 seconds, the rocket should reach a height of 112 feet. Now part C, how long will it take the rocket to hit its maximum height? Well, the maximum height would be the vertex of the parabola. And the vertex has a coordinate point of t, h, where the time would be the time it takes for it to reach that height, and the h would be the y value of the vertex, and that would be the actual height that it reaches at the maximum point. So to solve for how long it will take the rocket to reach its maximum height, we have x is equal to negative b over 2a, which in this case x is t, and t is equal to negative b over 2a. All right, so any maximum height formula, maximum height problem would be solved by getting the vertex of the parabola. And again, if we plug in the b and the a term, then we have negative, the b term is a 128 of the quadratic over twice a, and the a term is a negative 16. All right, and a double negative would be an overall positive, and we have 128 over twice 16 would be a 32. And 128 divided by 32, let me check what that would be. That gives us a 4. So after 4 seconds after being launched, we know that the rocket would be at a maximum height. Now part D is asking what the maximum height would be. Right? So we know that the rocket hits a maximum height after 4 seconds, which is the x value for the vertex. Now, by them asking you for the maximum height, they're asking you for the y value of the vertex. And to get the y value, you plug in your x value of 4 for every single x. We have h of 4. The height after 4 seconds would be a negative 16 times 4 squared plus 128 times 4. All right, so, and that gives us a negative 16 times 4 squared would be a 16. And then 128 times 4, let's check what that would be. That'd be a 512. All right, so negative 16 times 16 would be, I believe, a 256, but let me double check that. Yeah, so we have it's a negative 256 plus 512, and that would give us a positive 256. So we know that the maximum height that the rocket reaches would be 256 feet, and it reaches that height after 4 seconds. So part C and part D would be a combination that tells us what the vertex is for the parabola, and the vertex in this context would be the time and the height that the rocket is at the maximum point. All right, so that's number 2. Let's move on to number 3. So a rocket is launched from atop a 101-foot cliff with an initial velocity of 116 feet. Let's first draw that out. So we know that there's a 101-foot cliff, and a rocket's being launched off of that cliff, and that's the ground at the bottom. It's being launched in a parabolic motion, so it should look something like this. And again, the initial height of the cliff is 101 feet. All right, so let's read further. So part A says substitute the values into the vertical motion formula, and then let h of t equal to 0. So h of t for part A would be negative 16t squared. Now we know that the rocket was launched with the initial velocity of 116 feet per second, and that would be the b value for our quadratic. So plus we have a 116t, and then plus h initial, which in this case, the initial height that the rocket was launched from was 101 feet. All right, so, and then part B says use the quadratic formula to find out how long the rocket will take to hit the ground after it is launched, around to nearest tenth of a second. So when it's hitting the ground, we know that the height would be 0 feet above the ground, and we're solving for the time it takes us, or like it takes a rocket, for the rocket to reach a height of 0 feet. All right, so we can plug in a 0 for the height and solve for the t. So we have negative 16 t squared plus 116 t plus 101. All right, and we cannot divide everything by a common factor for this, so we have to resort to using our quadratic formula. So t is equal to negative b, which is negative 116, plus or minus the square root of b squared, so 116 squared, minus 4 times a times c, the entire quantity divided by twice the value of a, which a is a negative 16. All right, so let's keep on simplifying this until we end up with some value. We have a negative 116 plus or minus the square root of, now 116 squared, that would be a, let's check, that's going to be a 13,456. So we have 13,456, And then a negative times a negative gives us an overall positive symbol. And 4 times 16 times 101. Let me check what that would be. So 4 times 16 times 101. That gives us a 6,464. So 6,464. And the entire quantity divided by twice negative 16, which is a negative 32. All right, so from there, let's get the sum of 13,456 and 6,464. Let's check what that is. It's going to be a 19,920. So the final solution or like the simplified solution would be negative 116 plus or minus the square root of 19,920 divided by negative 32, which we can break it up now into two different solutions. The first one being a negative 116 plus the square root of 19,920 divided by negative 32. And the second solution being negative 116 minus the square root of 19,920 divided by negative 32. All right, so let's plug these into the calculator. So we have negative 116 plus the square root of 19,920 divided by negative 32. And that gives us a negative 0.786 approximately. And the second solution, which let me make the approximation symbol for that. Let's check what the minus version would be. Negative 116 minus the square root of 19,920 divided by negative 32. And that gives us a approximately 8.04. All right, so since time cannot be negative, the first solution would be extraneous. And that leaves us with 8.04 seconds would be the solution for our problem. So the rocket hits the ground after 8.04 seconds. And that's it for number 3. All right, so let's move on to number 4 now. So a rocketry club is holding a competition. There's cloud cover at 1,000 feet. If a rocket is launched with a velocity of 315 feet per second, use the function h of t is equal to negative 16 t should be a squared plus vt plus h initial to determine how long the rocket's out of sight. So if we draw this out, we're given that a rocket's being launched from ground level and it's going to reach some maximum height, after which it's going to go right back down. And that's what the path of the rocket should look like. All right, and there's cloud cover at the 1,000 feet level. So that's going to be somewhere over here, there's cloud cover. And there's going to be some interval of time t where the rocket would be out of sight. And that would occur right over here. Once it touches cloud cover at the 1,000 feet mark, so at that time value and then up until this time value over here, the rocket's going to be out of sight. It's going to be behind the clouds. So we're solving for the time at this point, which time would be t when the y value, the height, would be 1,000 feet. And then we're solving for the other time t where the height would be at 1,000 feet. So we should end up with two different time values for this because it touches the 1,000 feet level at two different points. So if we plug everything into our vertical motion formula, then h of t would be defined by negative 16 t squared plus v initial t, which v initial is given to be 315 feet per second. So you have 315 t, and then it's being launched from ground level, so the initial height would be a 0. And now we're solving for the time that it takes for the height to be 1,000 feet. So t would be our unknown variable when the height is equal to 1,000. So let's plug in 1,000 for our height value, and that's equivalent to negative 16 t squared plus 315 t. Okay, so to solve for time, let's subtract away 1,000 on both of our sides. And that gives us a 0 is equivalent to negative 16 t squared plus 315 t minus 1,000. Okay, so we cannot divide everything by a common factor for this, so let's plug everything into our quadratic formula. So t would be negative b, which is negative 315, plus or minus the square root of b squared minus 4ac. So that's 315 squared minus 4 times negative 16 times negative 1000. And the entire quantity divided by twice a, which a would be a negative 16. All right, and that gives us a negative 315 plus or minus the square root of, let's check what 315 squared is. So 315 squared gives us a 99,225. And then we have a negative times negative is an overall positive symbol. And that positive times one more negative would be an overall negative. And 4 times 16 is a 64. 64 times 1,000 gives you a 64,000. And that entire quantity divided by twice negative 16, which is a negative 32. Okay, and that simplifies on to negative 315 plus or minus the square root of, let's get the sum of the difference of these two numbers. And that should be, let me check right now, that would be a 35,225 divided by negative 32. All right, and this breaks up into two solutions. The first of which would be a negative 315 plus the square root of 35,225 divided by negative 32. And the second one being the minus version, so that's negative 315 minus the square root of 35,225 divided by negative 32. All right, and let's plug these into the calculator. So negative 315 plus the square root of 35,225 divided by negative 32, and that gives us a value of approximately 3.98. And the other t value, let's plug in the minus version. So negative 315 minus the square root of 35,225 divided by negative 32, and that gives us a 15.71. All right, so we know that it reaches a height of 1,000 feet after both 3.98 seconds and after 15.71 seconds. And to find out how long it's not going to be visible, let's subtract these two time values to see what the duration of time would be between these two intervals. So that would be 15.71 minus 3.98. And let's check what that is. So 15.71 minus 3.98, and that gives us a time of 11.73 seconds. All right, so after for 11.73 seconds, the rocket would be out of sight, and that would be the solution for this quadratic word problem.